All right, so this will focus on Chapter 3, Section 3. And if I look here, what I'm doing is I'm going through, and this is just a review of adding integers and subtracting integers. So pause this, try to figure it out. All right, well, here are the various answers. Again, remember that a negative and a negative is a positive. That's a big thing. And if you are subtracting 15 and subtracting 24, altogether you're subtracting 39. So these are the basic rules that we learned from Chapter 1. The essential question is, how can you use algebra tiles to solve addition and subtraction equations? And we'll practice them right here. So let's say I have x minus 3 equals negative 4. Now, these are expressions, these are now equations and not as expressions. And the difference is now I have an equal sign here. So I want to basically figure out what x is equal to make this statement true. Notice how I model it on the left side here. We have 1x and then 3 negative signs equals 4 negative signs. And what I want to do first is isolate the variable. So the variable here in this case is the x. There's nothing in front of it, but I want to get rid of everything else. And you'll notice that I added 3 positives because that would then zero these out, make them equal to 0 on this side. But with an equation, if you do something on one side, you have to do it to both sides. So I added the 3 positives here, and I also added over here as well. When I rewrite this, it says to get the variable tile by itself, remove the negative 3 is what I want to remove. So I'll put down negative 3. On the left, by adding 3 tiles, to each side. And then how many 0 pairs can you remove from each? Well, this is 1 0 pair, 0 pair, 0 pair. So now I have my x equals, and then on this side, these will cancel out, these will cancel out, and then these here will cancel out. And it looks like I'm left with just 1. So when I do that, x equals 1 negative sign. So negative 1 is the answer. Now algebraically, if I want to show this, all that I'm doing right now is I'm taking x minus 3 equals negative 4. And I want to isolate the variable, so I'm going to box this coefficient. And I'm going to do plus 3 here. Make a little line, plus 3. And now I have x equals negative 1. This is exactly the same thing I did over here. This is more visual, but some people like to see it like this. So here's some more. So I'm going to go through here. So I have z minus 6 equals 2. And pause the video and try to solve this for yourself. Now hopefully you paused it and you actually tried to solve it. First thing you're going to do is box the coefficient, make your little line. I want to get this 6 equal to 0, so I'm going to say plus 6. I'm adding because I have minus 6 here, so I have to add it. And I'll say plus 6 on this side. I now will look at it, and I'll have z equals 8. Of course, I can plug that in to see if it works. 8 minus 6, that does equal 2, so that works. I'm going to do the same thing for the next one. Again, I'll go p minus 7 equals negative 3. Draw my line, box the coefficient, right? I'm going to add 7 because I want to get it equal to 0, and add 7 here. And p equals 7 minus 3 is 4. I'll plug it in. 4 minus 7 is negative 3, so it totally works. And the last one that I'll do here is negative 15 equals t minus 5. It doesn't matter what side this letter is on, because an equal side just means that they're simply equal, right? So I'm going to box the coefficient just like I always do. I'm going to add 5, draw my line. I'm going to have t equals, this would equal negative 10. And this is equal to t equals negative 10. It doesn't matter what side, they're equal. So whatever, it's written the same way. So if I plug this in and I say negative 10 minus 5, that means I owe somebody $10, I owe them $5, altogether I owe them 15. So it works. All right, so then the next one here is negative 5 equals n plus 2. I'm going to box the coefficient. I'm going to subtract 2. I'm going to subtract 2. I want to get it equal to 0. Draw my line. and do the same thing on the other side. And now I'll have n, because this becomes a 0, right, equals -5 and -2 is -7. And I can plug this in to see if it works. -7 plus 2 is, in fact, -5. Now, to show you visually, I have my 5 negatives. I have my plus sign and my 2. I want to cancel these out, so I add 2 here. But if I add 2 here, I have to add 2 more on this side as well. I think these 0 out. And then I have my 1x, and this is equal to 1, 2, 3, 4, 5, 6, 7, negative. Well, -7 over there. So we're going to go through and same kind of thing where I just subtract 10. So in this case, y equals -15. This one here, b equals -8. And this one here, z equals -4. Sorry, I can't click through for some reason. This isn't working properly. There you go. So if I look at this one here, it says write an equation to show the algebra. I'm going to do that. So I'm going to go through, and on this side it's -4 equals x plus 1. That's what this shows. This one here is, that's for A. B is x minus 3 equals 3. C is x minus 5 equals -4. And then D is 5 equals x minus 2. And hopefully you can see all this when I go through it. If I want to solve these, I'm going to move this over here. So this would equal x is equal to -5. This one here, x is equal to 6. This one here, x is equal to 1. And this one here, x is equal to 7. You can plug these numbers in and you can actually see that they work. And this one here says we're looking for the melting point. Which equation could I find the melting point of mercury? So it says the melting point of the element bromine is 19. This is about 57 more than the melting point of mercury. So 57 more than mercury. And it's asking, what is the melting point of mercury? So if I think about this for a second, it says that the melting point of an element is 19, and this is about 57 more than the melting point of mercury. So I know that I have 19, and I'm going to subtract 57 to get an answer. If I look at these things here, I have to look at which one of these would give me the same thing, where x equals, and I guess I'll put down equals x. Which one of these statements will give me the same numbers? So if I go through the first one, I have x plus 57 equals 19, and I subtract 57 here, and I subtract 57 here, I will get x equals 19 minus 57, which is exactly what I have right here. If I do the other ones, it won't work because I'll have plus 57. This will be minus 19, and this would be minus 19 with negative 57. So the correct answer would be this one right here. Next one says I have 1x minus 3 equals 1. So write that down. So I'll say x minus 3, because there's 3 negative signs, equals 1. I want to go through and solve this. So I'm going to say, first of all, box a coefficient, add 3, add 3. I'll have x equals 4. And that is my answer. So then the key ideas that we're talking about are the addition property of equality and the subtraction property of equality, which is what I'm doing here. I'm just trying to make it equal to 0. Solve here. So if we go through, this will be x equals 5. And this one here this is a good one. Let's actually get this one down. So if I have z plus 3/2 equals 1/2. Well, what I want to do first is box that coefficient. So we're going to do exactly the same thing I always do. Draw a line. Oh boy, that's a big line. All right, box my coefficient. And I want to subtract 3/2. So minus 3/2 and minus 3/2. And when I do that, I'm going to have z equals, and then 1 minus 3 is -2 over 2. So then z equals -1 is what it says here. And when I do that, I will absolutely get 1/2, because if I break this apart, if you think about it, this is going to be really 2/2 plus 1/2. That's 3/2, right? And I'm basically getting rid of 1 whole. That's what it's saying. So get rid of this 1 whole. And I'd have 1/2 is equal to 1/2, and that makes total sense. This one here, I want to get p by itself, so I'll add 5 to both sides, and I'll have 3. And then this one here, if I go through, a company has a profit of $750 this week. This profit is $900 more than the profit from last week. So I have to figure out which equation would work here. So this has to be the profit is $750 minus $950. And I have to look here, which one of these things actually says that? Which would make this true? And if I look here, oh, I meant to say 900, not 950. And if I look here, the one that I think will actually do this, where I'll have a positive 750 and a minus 900, this will not work because this will be plus 750. This here would be minus 750. This here would be, I have to first move the p over here and then subtract 750. And this one here, I go minus 900. So B is the correct answer. So then this one here says solve an equation to find your square after level 4. So it looks like every single time. So this one shows that I have a -8 for this for my friend. It says that at level 4, I'm at -8, and I want to be at level 4, but it looks like I'm 33 points up. So I'm going to take -8 plus 33, and so that would be 25. So that means mine is 4 and 25. And really, that's what we're going to be working on from this one. There's a lot to it, but with more practice, I think you'll